Alright, in this lesson we're going to take a look at how to do an electron configuration. And all this is really doing is just mapping out which electrons exist in which energy levels and in which sublevels containing different shapes of orbitals. So the first thing you need to do when you're going to try to write out an electron configuration is determine how many electrons one atom of this element would have. So if we take a look at neon, you see its atomic number is 10. That means we have 10 electrons total in one atom. Now, if you take a look at your chart, you could either be your periodic table or your electron configurations reference sheet. You're going to notice some sort of scheme, some sort of diagram that shows you how these orbitals, these levels, fill up. And the first one that fills up is the 1s. Okay, 1 means the energy level it's in. S is the type of sublevel it is, the shape of the orbitals. Okay, and any S sublevel can hold 2 electrons. Okay, the next one that's going to fill up would be the 2s. It's still an S sublevel, but now it's in the second energy shell. Any S sublevel can hold 2 electrons. Okay, so far I've placed 4 out of the total of 10 electrons. Now, if I watch my chart, the next one that's going to fill up is the 2p sublevel. Second energy shell, but a different shape of orbitals. And the p sublevels can hold more electrons. They have a bigger capacity. They can hold 6. Okay? And now I kind of keep track of where I'm going here. If I were to take 2 plus 2 plus 6, I get 10. Okay? So the electron configuration is done. I've placed all 10 electrons. Okay? So what I'll finally have for my result is this right here. Okay? And all that's doing is showing me at the ground state, without any extra energy added, where those electrons would exist. Now let's look at something just a little bit bigger and see what we can do for some adjustments here. So if we look at phosphorus, phosphorus is a little bigger. It has 15 electrons. But we're going to start the same way. Every one of these start exactly the same way. First energy shell, S sublevel, can hold a total of 2 electrons. And we just start exactly the same way with each atom until we've run out of electrons to place. So the next sublevel is 2s, and it can hold 2 electrons. After that is 2p, and it can hold 6 electrons. Okay, then after 2p, if we look at our chart, we jump down to the third energy level. Okay. And the third energy level first has an S sublevel. Okay. Once again, S can only hold 2. After that comes the 3p. Now 3p can hold 6, but do we have 6 electrons left to place? If we count these, 2, 4, plus 6 gives me 10, plus 2 gives me 12, and I only have 15 to place. That means I have 3 more left. So I'm just going to put the final 3 electrons in the p sublevel, even though it doesn't fill it up. Now, as you can see, if we were to work our way down the periodic table to bigger and bigger atoms, these are going to get really, really long. So one way we abbreviate them is we just use the noble gases. And if you notice, the noble gases are the ones on the very right-hand column of your periodic table, and they're the elements that have all of their S and P sublevels completely filled up. So if you notice, this part of phosphorus, of the phosphorus electron configuration, looks just like neon's. It's exactly the same. The first 10 electrons are placed exactly the same as neon. So instead of writing them out, we could just write this. Neon, in brackets, basically takes care of the first 10 electrons. And then we say, and after that, we have 3s2 and 3p3. That stuff right there. Okay. So this right here has the same meaning, but it's a little less messy to write because we can take care of the first 10 electrons just by saying it's the same as the noble gas that comes before it.